Hey, welcome to the first lesson. So, in this lesson, we will be introducing deep learning to you. So, I will give you a brief description, a definition, and we will take like a high level overlook into deep learning. And I want to do this because I want to make sure that we are familiar with what the general landscape looks like when it comes to deep learning. And, just so that we're introducing things a little bit slowly. So, first things first, a definition of deep learning. So, if someone asks me what deep learning is, what I basically say is it is a discipline of artificial intelligence and it is based on neural networks. And it has the power, as different from normal traditional machine learning, it has the power to learn complex patterns directly from the data. But don't worry if it's not completely clear to you, it will become more and more clear as we go along. So, it is called deep learning, right? And you might be wondering, why is it called deep learning? What is deep about it? So the deepness comes from the number of things that we stack on top of each other. So you will see in a second, deep learning is basically layers of neurons stacked one after each other. So that's why at the end you have a lot of layers, and these layers make it deep, and that's why it's called deep learning. And the learning side comes from machine learning. So if you have done normal machine learning work before, maybe you've taken my data science Kickstarter course, the free mini course that I have. There you might have seen the general landscape of AI, and you know then that artificial intelligence is part of computer science and machine learning is part of artificial intelligence. Well, we follow along in that logic, and deep learning is part of machine learning. It's one technique of machine learning, and that's where learning comes from. So if we show it on a better diagram, let's say, we have computer science that might have a lot of different disciplines. So it could be computer security, it could be web development, software development, cryptography, I think, is part of it, or artificial intelligence. So artificial intelligence is just one thing computer scientists do research on. And machine learning is one approach that you take to artificial intelligence. And deep learning is a little bit smaller group. So every time you say deep learning, actually machine learning contains deep learning. But deep learning is just one approach or one group of techniques, let's say, that is in the machine learning approach to artificial intelligence, if that makes sense. So how are machine learning and deep learning techniques different? Of course, this is the next question, right? Because we see machine learning contains deep learning, but how are they different? Why is deep learning a separate thing other than machine learning? So how a machine learning system works is that, let's say you have photos of cats and dogs. This is a very common example. And you want your model to know how to distinguish between cat and dog photos. So you want your model to look at a cat photo, say this is a cat, and look at a dog photo, say this is a dog. What you would do in a traditional working progress is you take the data. In this case, it is a photo. It's a kind of angry looking cat, but it's cute. And then you have to extract features. So you would have to say, maybe you would have to give the angles of the ears, or you would say it has two pointy ears. You would have to give the angles of like the chins and everything. So you would have to do the extraction of information, and you would have to put it in a structured table or a data frame. This could be called in Python and Pandas, and then feed it to the data. Feed it to the model. And then your model will learn how everything works. And then it will start seeing patterns of like, oh, when it has two pointy ears, then it's a cat. But when it has two round ears, then it's a dog, sort of thing. Then your model with the examples will learn, and then it will be able to say, it's a cat. Whereas for deep learning models, it's a little bit different. In deep learning models, you just say, hey, here's a photo. And then the model learns by itself. Of course, we will go into how everything works, how do they learn, and all the theory behind it. But you just basically say, hey, here's a photo. And then the model basically says, oh yeah, it's a cat. I know that because, you fed the data to it before and it's aware of it. But of course, this is not the only difference. So if we want to look kind of like on a high level how they are different, of course, the working system is different. But one thing that's good to know is because the deep learning model is able to learn directly from the data without us doing anything manual, then it needs many more examples. So if you're able to train a decision tree, which is a traditional machine learning algorithm, with just 100 examples of cats and 100 examples of dogs, and it's able to say, tell the difference. For deep learning, you would need 500, 1,000, maybe 5,000 examples. So that's basically this nice thing comes with a cost at the end. The next thing is, we talked about it, machine learning systems need feature generation, manual feature generation, and deep learning systems don't. But of course, again, as a consequence of directly learning from the data, these are more complex systems, deep learning ones. These are more complex systems. There's much more complex calculations needed to actually learn how the patterns work. That's why you need more training time and more computational power. But those are kind of like trade-off things. If you have less computational power, it's going to take more time. If you have more computational power, it's going to take a little bit less. So maybe you can easily train a machine learning model in 20 minutes, sometimes even a couple of seconds, but a deep learning model will take 5 hours. It might even, it's normal for it to take 2 days. People train models that will take 2 or more days even. But basically lately, that's the nice thing. In the last 10 years, people, mathematicians, computer scientists figured out ways to actually make it run faster, and also kind of make it feasible to run at the end. But this is kind of course, there will be deep learning models that you can make that will run very fast, right? In this course, we will also do a lot of exercises, create models that will run pretty quickly in a couple of not even minutes, like 30 seconds or something. But if you want to do, of course, real life applications, you would use a lot of data, and it would include a lot of complexity. So at the end, it's going to take quite a lot of time. So these are just kind of like high-level comparisons of what's going to happen. But apart from the things that we can easily compare and see, like the time, how much data is needed, one thing I find that's kind of not really mentioned out there, but deep learning has the chance to work on a bit more abstract tasks. So it can deal with complexity a little bit better, so if you need to extract features from the data and do that manually, you might say, yeah, you know what, I don't actually mind it. I'll do the feature extraction, but you might not be able to all the time. Sometimes you might not know how to extract the features. You might not know where you should look into. And at that point, deep learning is very useful, especially when it comes to computer vision, for example, or natural language processing. Maybe you want to do sentiment analysis, but how sentiment analysis is basically giving it a sentence and seeing, is it a positive sentence, does it have a positive connotation or a negative? It's kind of like movie reviews, if someone says, I love this movie, it's amazing. Yeah, okay, it's positive. It's like, oh, the waste of my time or something like that is negative. So that's called sentiment analysis. A little note in there. But so in a case like that, with machine learning algorithms, you would not really know what kind of features to extract. What are you going to say? Here are some positive words, the count of positive words in the sentence. Well, people can be sarcastic. Maybe they'll say, yeah, it was an amazing movie, right? So maybe, then it sounds actually very positive, but at the end it will be negative. So at that point, it becomes a very abstract task of what you should look into. But deep learning is really good at this. It's really understanding what's going on with language and just, without tiring you, coming up with its own patterns, coming up with its own rules of what to look into and following those things. So we said deep learning is based, or at least it started with neural networks. So what are neural networks? We will look into neural networks in much more detail, but just to kind of give you an image of what it is. So neural networks are structured like this. They have input layers, they have hidden layers, and they have an output. So all these little dots that you see are called neurons. They have an input, they have an output, and they calculate something inside themselves. So it's basically think of it like a mathematics function. Let's say I am a function and I say, whatever you input to me, I will multiply it by 5, add 3 to it, and then output it. Basically like that. There is a function in here, you input something, it calculates something, it outputs something, and it sends it to all the other neurons in the next layer. And again, same thing happens here. Something's calculated, it's sent to the next layer. And then something's calculated here, and then it's the output. So how this works, just one example. Let's say we have structured data. We have 3 input points. You can think of this as the features in your data set. Let's say we have an age column. We have a whether someone has a job or not column, and how much debt they have right now. So we're saying, okay, this person is 29 years old, they have a job, and they have 0 debt. Something gets calculated here, sent to the next layer, something is calculated here, sent to the next layer, and then they say the last layer, the output layer says, this person is good to lend some money. Awesome. But how do we do it with other types of data? So another example could be the detecting what's written on a handwritten digit. So this is a very famous data set. You might have heard about it. I think it's like MNIST. It's like MNIST. Never know how to actually pronounce it. I just say MNIST in my head. I think that's the right way to say it. Then we have a 28 to 28 pixel image. You might not be familiar with this, of course, but images are made from pixels. So because this is a very small image, you can see all the pixels here, all these little squares, and this is a grayscale image, so it only has black and white and grays in between. So the pixels actually are basically numbers. So the black ones maybe have, if I'm not mistaken, I think black should be 1. So it's the darker places, and white is 0. By the way, it might be vice versa, so don't take my word for it, but I think blacks are 1 and whites are 0. And this one here, this gray one, for example, could be like 0.3 or something like that. And based on that, they take a value. And if I want to see, okay, here is my image, neural network, tell me what this number is. How you're going to train your neural network is each of these neurons in the input layer is going to take one value from pixels. So if you have 28 times 28 pixels, then you're going to have 784 pixels. So then you're going to need 784 neurons. But this is not the most ideal way of doing things. We'll talk about this later, just as an example. And then these neurons are going to give their calculated inputs. I forgot to put one connection here apparently, but this one is also connected. Every neuron is connected to the every next neuron, just so you know. Something is calculated, sent to the next layer, something is calculated again, and then it will be sent to the output layer. And the output layer has 1 neuron per every possibility. So then the first neuron gives us the possibility of this image being 1. The second one gives us the possibility of this being 2. And it goes like this. And at the end, you basically train your system. Maybe, then you give this 8 and it's going to say, oh, only 0.3 chance that this is an image of 1. And basically, yeah, that's how it works. So, but when we talk about deep, as I said, we're talking about many stacks of things. And what I mean is that here, as you say, we only have one hidden layer here. But when you make something deep, it means that there's going to be more than one hidden layer. You always have one input layer and one output layer, but you can put a lot of hidden layers. And in the hidden layers, you can put a lot of neurons too. But the amount of neurons do not make a neural network deep. The amount of layers do. So this is one layer and this is another layer. The amount of layers makes something deep. So if you have a lot of layers, you have a deep neural network. But of course, this is not the only way how a deep learning algorithm might look like. Then you start seeing, the further you go into it, the more different architectures you're going to see. These two, we're definitely going to look into recurrent neural networks and convolutional neural networks. So don't worry if this looks like, oh my God, what happened here? Because at the end of this course, you will be able to really comfortably understand what's going on, and this will not be scary anymore. There are some other techniques too, though. So as I said, there are deep neural networks, which is basically these guys. Then you have convolutional neural networks and recurrent neural networks. Convolutional neural networks are used more with image data and kind of like with computer vision things, whereas recurrent neural networks are used more with like sequential data. So this could be audio, this could be text, this could be speech, basically, what I'm saying right now, like NLP, which stands for natural language processing. Those are the most common ones that are used. But of course, then you have a lot of other different types of techniques too. For example, generative adversarial networks, which I always have a lot of trouble pronouncing, reinforcement learning, autoencoders, transformers, deep Boltzmann machines, and deep belief networks. And I'm sure if you looked into it, you could find even more, because basically there are like new papers and new technologies coming out every year, even every month. When I was working with recurrent neural networks, I was looking into some things. I was reading papers on trying to figure out, okay, how can we do this thing that we're trying to do? And transformers came out like 2 months before that, and I was reading this transformers paper, and I'm like, wait a minute, this paper came out like 2 months ago, and it's already something that people use. So it's super cool. If you want, you can go further into what you want to learn, but I would highly suggest at first to really specialize in deep neural networks and convolutional and recurrent neural networks, because once you kind of get the sense of how they work, everything else will be a little bit easier. But as I said, in this course, we will be focusing on the top 3. By the way, just as a note, if you're the kind of person who's looking for some sort of logic in the color scheme here, if I made some color coding, I didn't. I just tried to make it look nice, just so you know, because I feel like I would have looked for a color-coded pattern here, but there is none. Okay, so the last thing that I want to say is I will upload these slides on the course page, so you can easily go ahead and look at the slides, and at the end you will have these links. These are just some of the interesting things that I come across on the internet. I thought you might be interested in that too. So first one is a application of deep learning where someone draws something. Let's say draws like a green circle and something blue next to it. All of a sudden it can be turned into an actual looking painting or a photo of a landscape. The second one is a system predicting while someone is walking where they're going to walk to, if there's another person approaching, if they're going to say hi or not. So these are very interesting things. I will keep adding things to this one as I see them, but if you're interested, go check it out. All right, so now we're done with this part. Again, I will also have some summaries of these lessons in PDF format, so you can go see those ones too. You can download it, keep it with you at all times, just in case. And in the next lesson, we will be going into the building block. Nice pronunciation. We will go into the building blocks of deep learning. So we're going to be getting a little bit more detail, a little bit more math, a tiny bit math, just to, so that we're comfortable with how everything is going. But yeah, I hope this was clear, and see you in the next lesson.